So we have another challenging and fun issue to deal with when we're doing this algebraic structure and going through the solving process. Over here on the right, you'll see I have an equation, and there's variables, the variable w, all over the place. And the challenge here is, how do you tell the story? How do you tell that construction story of w in this case when there's so many w's? Whose story are we going to tell? So this equation is not ready to be solved in this construction, deconstruction kind of a way. We have to do some work first to get it story ready. And so I got to back up a little bit and share some things that'll help us to do just that. First thing is just to kind of establish some thinking. So please organize your brain or get your brain in a mindset of, okay, I'm just going to try to make sense of something and try to and see some structure and understanding. So up here I've got a little thing going on. 3 times 2 plus 1. Now 3 times 2 is 6 plus 1 is 7. And over here 4 times 2 is 8 minus 1 is 7. What I'm trying to say is there's a couple of ways you could figure out 7. Now I just randomly picked 3 times 2 is 6 plus 1 is 7, but also 4 times 2 is 8 minus 1. They're both 7. And the reason I did this is I wanted you to see a little something. This is 3 copies of 2. 2, 4, 6. 3 copies of 2 plus 1 is 7. This is 4 copies of 2. 2, 4, 6, 8. Minus 1 is also 7. Now watch this. Suppose I wanted to create a few more of these in the same structure of so many copies of 2, so many copies of 2. I'm always going to add 1 over here. I'm always going to subtract 1 over here. But I want you to see some other ways that we could do it. For example, what if on this side, instead of 4 copies of 2, what if I only had 3 copies of 2 minus 1? And I still want to have an inequality here. Like up here we had 7 on both sides. I still want to have an equality, but watch this. If I take away a copy of 2, 3 times 2 is 6, minus 1 would be 5. On this side, I would have to also take away a copy of 2. Instead of 3 copies of 2, I'd have to have 2 copies of 2 plus 1 is still 5. 4 plus 1 is 5. 6 minus 1 is 5. The point here is, if I remove a copy of 2 from one side, I have to remove a copy of 2 from the other side in order to maintain the equality. Or, now we're going to go back up to this top line. If I had 4 copies of 2, what if I added a copy of 2? What if I had 5 copies of 2? 5 times 2 is 10, minus 1 would be 9. Now again, I want to maintain equality, so from here to here, I went from 4 to 5 copies of 2. I increased my copies of 2 by 1. I would have to increase my copies of 2 on this side as well. So instead of 3 copies of 2, I'd have to have 4 copies of 2 plus 1 is still 9. So my point is, if I go from 4 copies of 2 to 5 copies of 2, I'd have to go from 3 copies of 2 to 4 copies of 2 to maintain an equality. Or one more, watch this. What if on this side, I went from 4 to 3 to 5? What if this time I'm going to go to 0? I'm going to have 0 copies of 2. In other words, 0 copies of 2 is just 0. I got nothing. Now on this side, what would I have to do to have that equality? Now I went from 4 copies of 2 to no copies of 2. I removed all 4 copies of 2. To maintain equality, I'd have to remove 4 copies of 2 from this side as well. So if I remove 1 copy of 2, 2 copies of 2, I can remove 3 copies of 2 to get to 0, but I have to remove 4 copies of 2. So 1 more copy of 2 would leave me with -1 copies of 2. Now, 0 copies of 2, 0 minus 1. 0 minus 1 is -1. -1 copy of 2. -1 times 2 is -2. And -2 plus 1 is indeed -1. Check your calculator if you need to. But here's the point. If I remove 4 copies of 2 to have none, I would have to remove 4 copies of 2 to have -1 in order to maintain equality. Bottom line is, what I'm saying is, if I want to maintain equality If I remove or add from one side, I would have to remove or add from the other side as well. Keep that principle in mind. When we get over here, you'll see that principle at work. All right, second principle. Take a look down here. What this says to me is I've got 3 copies of 2 plus 4. In other words, I've got 2 plus 4 once. I've got 2 plus 4 twice. I've got 2 plus 4 3 times. I've got 3 copies of 2 plus 4. Now I know you're thinking 2 plus 4 is 6. 3 times 6 is 18. Why doesn't he just do that? Because that's not the point. The point is I want you to see this equality one more time. So 3 copies of 2 plus 4. 2 plus 4 is 6 plus 6 plus 6 is also 18. This is 18, this is 18. But watch this. What I want you to see is this. 1, 2, 3. I have 3 copies of 2. 1, 2, 3. I have 3 copies of 4. 3 copies of 2 is 6. 3 copies of 4 is 12. 6 plus 12, still 18. This is 18. This is 18. This is 18. They're all 18. You need to see, for this guy over here, you need to see that we can express ideas in multiple ways. We can say 18 as 3 copies of 2 plus 4. We can say 18 as 2 plus 4 copied 3 times. We can say 18 as 3 copies of 2, 3 copies of 4. Now, when we do this, when we say 3 copies of 2 plus 4 is the same as 3 copies of 2 plus 3 copies of 4, when we say that, we're applying what's known as the distributive property. And you saw that in a previous module if you've been doing the modules. But that's what that is. So, suppose we have an algebraic situation. Look, here I have 3 copies of x plus 2. In other words, I have x plus 2, I have x plus 2, I have x plus 2. I've got 3 copies of x plus 2. Just like up here, this is equivalent to this. They both gave 18. This is equivalent to this. I don't know what it gives because x is a variable. It's unknown. But 1, 2, 3. You have 3 copies of x. 1, 2, 3. You have 3 copies of 2. That's another way you could say it. So bottom line is 3 copies of x plus 2 is equivalently written as 3 copies of x, right there, plus 3 copies of 2, right there. All of these things are the same way to express the same notion. Now you can do that with negatives as well. So here's how I'm going to read this. First of all, I want to focus on that I have 2 copies of w minus 3. That is, I have w minus 3 twice. Now, I do have to negate that whole thing. You'll see. But first of all, you see the 2 copies of w minus 3. Now, 2 copies of w minus 3. There's a copy of w, there's a second copy of w, there's 2 copies of w. I hope you see that. There's also 2 copies of negative 3. But then you have to negate the whole thing. And when you negate the whole thing, you're going to get the opposite of. Remember back in early modules that negative sign can be thought of as the opposite of. So the opposite of 2 times w is negative 2 times w. And the opposite of 2 times negative 3. Now let's think about 2 times negative 3. 2 times negative 3 would be negative 6. And the opposite of that would be positive 6. So it would be 2 times 3. In terms of distributive property, this is a way you could say it, this is a way you could say it, or this is a way you could say it. Negative 2 times w minus 3 is the same thing as negative 2 times w. You see it? Plus 2 times 3 because negative times a negative is a positive, or the opposite of the negative is a positive. Either way you see it is all good. So, principle one, if you take some quantity off of one side, take the other quantity off of this side to maintain that equality. If you take off all four, you're going to take off all four in order to maintain that equality. Distributive property. Okay, with those two things, you can get this guy story ready. Watch. Do you see an opportunity for the distributive property here? 5 copies of 6 minus w. 5 copies of 6 minus w is 6 minus w, 6 minus w, 6 minus w, 6 minus w, 6 minus w. I hope I just did 5 of them. That's the same thing as having 5 copies of 6 and 5 copies of minus w. Now, yes, we are going to need the opposite of that. So using the distributive property, we can kind of clean things up over here. Now, likewise over here, 2 copies of 3w minus 1. Can you imagine a 3w minus 1 and a 3w minus 1? You'd have 2 3w's, that would be 6w's. You'd have 2 of those minus 1's, that would be minus 2. That's the distributive property at play. Now, just stay with me here for just one more minute before we apply this principle. So far we've done the distributive property a couple of times. Now we're going to apply one more principle. Look right here. You got 4w, you get 5w's. In other words, you have 4 copies of w plus 5 copies of w. If you have 4 copies of w and 5 copies of w, you got yourself 9 copies of w. Now over here, you got a 5 minus 2. Let's just make that nice and neat. 5 minus 2, 3. So, distributive property, kind of make things look a little neater. We call this combining the like terms, like grouping together how many W's do you have, combining together how many just numbers, constants do we have. All right, now let's use this principle. If you have 6 copies of w on one side, you could write an equivalent expression like this. Let's go from 6 copies of w to 0 copies of w. Now, if you remove 6 copies of w from this side, you have to remove 6 copies of w from this side. So this side had 9 copies of w. Let's remove 6 copies of w. That would leave me with 3 copies of w. So, using this principle, like remember we took 4 copies of 2 away? We have to take away 4 copies of 2. Here, we're taking away 6 copies of w. We have to take away 6 copies of w, leaving you 3. If you have 9, you take away 6, you're left with 3 copies of w. Now, 0 copies of w. Whatever w is, if you multiply it by 0, you get 0. So what you can say is 0 plus 3 is 3. There you are. So with these steps, I've gone from kind of a mess to a what we call story-ready equation. Now, at this stage, we're not going to write the construction story, write the deconstruction story, and solve. We're just going to talk it through. Construction. W gets multiplied by 3. Subtract 30. The result is 3. Deconstruction. We're going to do the opposite of that. So the opposite of that would be, start with your construction equals 3, but now in the deconstruct story, the last thing that we had done was subtract 30. So now we're going to add 30. Now again, from a logic perspective, if this 3w is 33, that's what it says. 3w is the same as 33. So imagine a 33 minus 30 is 3. Yeah. So it's just a logical next step. Now, in our construction story, w got multiplied by 3. We're now going to divide by 3. 33 divided by 3? 11. 3 times W. If W is 11, 3 times 11 is 33. So there you go. We just solved the equation. If you want to check it, you can. Let's do just a quick check. If W really is 11, 4 times 11. Remember, W is 11. 4 times 11 is 44. Minus 5 times 6 minus W. 6 minus 11 is equal to 5 plus 2 times 3 times 11. That would be 33 minus 1. Let's see what happens here. 6 minus 11. Negative 5. 5 times negative 5. Negative 25. Minus that. So 44 minus negative 25. 44 minus negative 25. Check your calculator if you need to. I think that's going to give us 69. 33 minus 1, 32. Times 2, 64. 5 plus 64, also 69. So yes, W equals 11 does indeed work. So try this. Do you make sense of this taking things or adding things off of both sides idea? Do you get the distributive property? Apply it, apply it, apply it, apply it, apply it until you get to something that looks nice and camera story ready. Story ready. If that helps, you'll have some problems to practice on. Have fun with it.